Hello, and welcome to my demonstration of the SAM programming language and the SAM processor for the ECE Thread Innovate Challenge. As you can see here, I have a program called correct.sam written in my SAM programming language. I'll show you how the whole process works, but for now, I'll show you the output. We run this program through the SAM processor, and we get output all the answers. So now, of course, the first thing you have to do when creating a programming language is to create the grammar. So here's the SAM grammar. And as you can see, we have three different non-terminals. We have the program, which is the starting rule, which is the program contains one or more statements. And a statement, like I said, is either a bunch of expressions or it's an assignment to a variable followed by a bunch of expressions. And then an expression can either be expression plus expression, an integer, a variable, or an expression within parentheses. Now, of course, a grammar isn't just good enough. And as we see, this is the grammar written in the .g4 format. And this is so we can run this grammar through the Antler tool, which is an online tool available to anyone. I recommend going to check that out. But that tool essentially takes a grammar that you write and then outputs a generated lexer and parser for that program to which then acts as the front end of a compiler or implementation of a code generator. So first we have our main driver that first will create the lexer, which then creates the tokens, which then you pass into the parser, and then that returns the tree. And then we will take that tree and use it to pass it into my SAM generator. And as we can see over here, the SAM generator basically goes through each node in the tree where each one is a different non-terminal. So obviously it visits the program, and essentially what we do is just visit all the children of it, which end up being all the statements. As you can see, finally, we have our visit expression. And then down here, we see our helper functions, which help build the instructions that our SAM processor will then read. We have the load I to load an immediate value. So anytime there's a number, we have the add to add two registers together, the output, which then our processor will output whatever is at the register we pass it, and move, which takes a value in one register and moves it to another. Then once this is run, we write that to the program.mem file. And as you can see, it's just a file containing where each line has a 32-bit number that our processor will read and decode to figure out what instructions should be run. And then we check out our SAM processor, which is written in Verilog. And as you can see, it takes in its only input is the clock, and then it has two stages. The first stage, it reads the instruction from memory at our PC address, our program counter, and then obviously the program counter will increment by one. And then the second stage, we decode the instruction and we get all these values. And then depending on what instruction is passed in, for example, if it's a load I, we will then take the immediate value, so whatever number we passed in, and add that to the register at the destination that we've determined. And then eventually this all runs through, and then we set this out valid to one whenever it's an output, and then that tells our simulator test bench written in C++ to then output to our terminal the output that is given. So as we see, we'll run this here, and as you can see, it runs again. And then say, for example, instead of 9 plus 19, we say 9 plus 10. We run it again, and now it's 19 because our processor was updated. And yeah, that's all.